18.2. Okay, in this video we're going to talk about the exothermic nature of neutralization. So first of all, okay, exothermic nature of neutralization, it means that our energy is released to the surrounding. In this setup, you can see that we put a thermometer in the solution. So this solutions, if we have the NaOH together, we add acid in it, then neutralization will happen in this expanded polystyrene cup. So the energy will be given out to the surrounding. As thermometer is one of the surroundings, so when the thermometer absorbs the heat, then you will find that the temperature it will goes up like this. Okay, so exothermic nature, that means that when you hold the beaker which have neutralization happens in it, you will feel warm. Okay, because during that the reaction mixture is giving out energy. Okay, energy is given out to the surrounding. So for this setup, do pay attention. Okay, you have to remember how to sketch it. So basically, you need a big polystyrene cup, and then outside you have a beaker there. And you have the solutions like NaOH in this case, and then we put a thermometer in it. Okay, so you have a bulb like this. So what you need to do is just add HCl in it. This will be a basic setup or to show the exothermic nature of neutralization. In this setup, we have used two apparatus. First of all, we have expanded polystyrene cup and we have a beaker outside. The beaker, the function of the beaker actually is to trap some air, in the middle. So you have to notice that, the expanded polystyrene cup and also the air between the cup and the beaker, both of them, because they are poor heat conductor, so therefore we can reduce heat loss to the surrounding. Pay attention to the words that we've used. It is reduce heat loss to surrounding, but we are not preventing heat loss to surrounding because it is impossible for us to prevent heat loss to surrounding. So pay attention to this. So with a quick look of an example 18.2. For this one, you'll find that we are having two sets of neutralization. The first experiments, we have NaOH, HCl. They have 2m 25 cm cube, 2m 25 cm cube, while the other one is KOH and HNO3. Both of them, you see that they are strong alkaline, strong acid. The only difference, it will be the volume. The molarity is the same, but the volumes, you find that one is 25, one is 50. One is 25, one is 50. So more or less, you'll find that the second one, is the double volume of the first one. But you'll find that the temperature more or less is the same. So for these examples, I strongly recommend you to revise part C. That one is the most important, and we always see that in the DSE exam. So I'll just have a quick look of AB first. A, explain why expanded polystyrene cup instead of beaker is used. Just like what we have mentioned just now. Expanded polystyrene cup is a poor conductor of heat, so therefore they can reduce heat loss to the surrounding. Part B, explain why the reaction in both experiments can be represented by the same ionic equation. To be honest, I don't like these explanations right here. We can have a look. Both experiments are represented by the same ionic equation. Why we can do that? If you can record the videos that we have learned before. We said that when we write ionic equation, all the acid, they will give out the H plus. The only problem it comes from the alkaline, or the base. In this situation, we found that both of them, NaOH and KOH, they are alkaline instead of some insoluble base. So therefore, in this, we can say that the alkaline dissociate in water to give OH minus. So for me, I won't write something like in B1. For me, I would prefer to say that because both NaOH, KOH are alkaline. They dissociate in water to give hydroxide ion, which react directly with H plus ion to form H2O. Then you say that therefore we can represent both reaction with same ion equation. The key focus is because both of them are alkaline. If one of them they are not alkaline, then in the ion equation, then you have to present like metal oxide, metal hydroxide to write as a whole, okay, without breaking it down into ions. So I preferred my answering, okay, more than the one in B1. So the ion equation, okay, just how we mentioned, it is alkaline and also acid. So therefore, it will be H plus OH minus to give H2O, okay, like what they have written, okay, here. Okay, so the key point comes to part C. Okay, explain why temperature changes in both experiments are roughly the same, even though okay we have used different volume of solutions. So the main difference, okay, right here you will find that okay one is 50 cm cube more than the one in experiment 1 that we have done. Okay, so you just consider things like this. Okay, when we have a beaker. If okay we have 25 cm cube like this, okay, I got 1 particle. So when I have 2 beaker, okay, they got 1 particle. When they add up together, it will be doubled the volume. And then because this is H plus, let's say this is H plus, this is OH minus. After they will form 1 H2O. This is what happened in experiment 1. But in experiment 2, okay, we'll find that okay we have initial volume will be double already at the beginning because we have double the volume. If you use the equations, okay, our number of mole equals to m times v. If volume is double, molarity is the same. Then you will find that okay the number of moles should be double. So you see that here I have drawn 2 particles in this volume. So when the acid and alkaline, okay, it happens something like this. Both of them they have 2. So when they add together, mixing up together, then you'll find that the volume will be much more than the previous one, double. Is that right? But the number of water formed will also be double. So if looking at this one, we see that in experiment 1 we can form 1 H2O molecule. But in experiment 2, because we double the volume, so therefore we form 2 H2O molecule. However, there is also one changes in it, not only the number of H2O molecule difference, but also the total volume. You see that this volume is also double because this one should be 100 cm cube. But this one we just have 50 because we have 25 plus 25. So this one is 25 plus 25. This one is 50 plus 50. So the volume is also different, okay? So the concept is like this. Because neutralization and the process of this, okay, they will give out heat. When you form 1 H2O, they give out 1 H2O, they give out certain amount of energy. Later on, you'll learn about this one, okay? They give out certain amount of energy. But if you form 2 water molecules, then the energy given out will be double. So basically, okay, if you have this concept, okay, the more neutralization you form, the more energy will be given out. Then you will see that this one, the energy given out in experiment 1 should be less than that, okay, in experiment 2. But the second concept that we have to pay attention to is the energy we release, how much volume you're going to heat up with. For example, in this one, you just have 25 cm cube. You have 50 cm cube. But for this one, you have 100 cm cube. Correct, you have more energy release, but you're going to boil a double volume. So in this case, we found that, okay, even you double energy release, you are going to boil double volume. Then in this case, actually, it will just break even. Okay, so you will find that in this case, okay, the temperature rise will be more or less the same as this one. Okay, so it sounds very complicated in the process. Okay, when we try to present in words, okay, how does it look like? Okay, so you can have a look here. So just look at how they're going to say. So in experiment 2, okay, although the volume of solution used are doubled, okay, the number of moles of H plus OH minus react are also doubled. So you address the volumes we have used doubled, and the number of mole of water formed is also doubled. Okay, and if we have formed double amount of H2O, what happened to it? Twice as much heat is given out. This is the fact. They give out double amount of energy. However, this double amount of energy, okay, is going to use to heat up twice the volume of the solution. The volume is also doubles. So you will find that, okay, at the end, okay, the temperature roughly, okay, will have the same rises. Okay, so basically part C is a very important example, and I think that you may find that, okay, this form of writing is typical for you to explain as well. So I highly recommend you to mark this down, okay, and memorize away the explanations, okay, because it will be difficult for you to write it on your own. So the experiments, okay, if we drop down the temperature rise, okay, during the experiments, we'll see something like this. Okay, so at the beginning, okay, it will be around 20 something. That will be the room temperature. When we add volume of acid or alkaline, we add in it, okay, then you'll find that if it is acid, say for example, if it is acid, and then we add NaOH 1 cm cube at a time, or 5 cm cube at a time, then you'll find that every time when I add in it, okay, the temperature will goes up like this. Okay, so there may be a temperature measurements issues, so it is not necessary for on one straight line, and this one, okay, will then keep on after you add, okay, after for a while it will then goes down. The problem is, okay, one of the techniques is how to find the highest temperature of the reaction mixture. Okay, when you look at these questions, okay, you will be very quickly say that, oh, must be this one. Okay, that is the highest point. Okay, so I will say for example, that will be 35.4, okay, cm cube. Okay, is it 35.4 cm cube? Well, the answer is no. Okay, because if you take a closer look, okay, maybe, okay, the reaction is not really whole number digits. It's not really 5 cm cube. Then it rises to the highest temperature. Maybe somewhere here, okay, up in the middle. Okay, so therefore, okay, if I just point out the highest point, that will be a mistake. So how we're going to do it? Okay, so we'll do the following step. So we will draw two best fit line. Okay, one to the left, all those data on the left. Okay, the other one, okay, will be all those data on the right, and then we will draw two best fit line. Okay, try to pass through as many dots as possible. If those dots, okay, is not passing through, or better to arrange them, okay, to have on the left of the line, and on the some of them will be on the right of the line, like this one. Some of them on the right, some of them on the left. So after two lines construct, the highest point, okay, it will be the intersection, okay, between two lines. Okay, so you have to know that, okay, why this setup, okay, we have two sections. Okay, the first part, okay, you'll find that the temperature keep on rising. For this one, okay, you have to know that, okay, neutralization is an exothermic reaction. So when we have our neutralization happens, okay, energy will be given out to the surrounding. Okay, so therefore the temperature will rises. Okay, energy is given out, so therefore temperature rises. Okay, but after the neutralization have finished, this is the point that where the end of neutralization. Say for example, okay, at the beginning of the setup for this one, maybe we got 3H plus in it. So after adding certain number of volume of alkaline, where all the H plus in it have been reacted, they may be changed to other things. Say for example, okay, the 3H plus become 3H2O. So in this case, okay, you will find that all the neutralization have finished, and okay, if you further add the alkaline, they will just cool the reaction mixture. So this one, excess, say for example OH minus or acid added, will cool the reaction mixture. Okay, so basically you think that, okay, if we have like a solution like this, okay, it is now 50 degrees Celsius, and then I don't care what kind of chemical you add in it, and then you just add, okay, increase the volume here. Definitely, okay, the energy will disperse, okay, to the newly added solution. So therefore, the temperature will then drop. For example, drop 5 degrees Celsius like this. So excess OH minus or acid, okay, added, okay, will only result in the dropping of the temperature, okay, because the reactions to neutralization have already completed. Get it? So class practice 18.2, okay, this one is also a very interesting experiment, okay. So part A, okay, find the graph above. What is the volume of NaOH needed to neutralize the acid completely? This one, okay, we don't have any data, and then it just plot the graph for you already. So just read, okay, the volume of NaOH needed. The highest point, okay, you draw down, then you'll find that the highest point, okay, we need 20 cm3 NaOH to neutralize it. Okay, the things that I would like you to pay attention to will be part B, part C, and also part E. So for part B, okay, after adding 30 cm3, the resulting solution was tested with a pH paper. Predict whether the new resulting solution acidic, neutral, or alkaline. If you notice that, okay, at this point, okay, this point is the point that the neutralization complete. Neutralization completed. That means that at this point, okay, they will only have salt solution. If you add excess, in this case, we're adding excess NaOH in a salt solution, you will only bring up the pH because you give more alkaline in it. So therefore, for part B, we'll expect that, okay, an alkaline solutions will be given. Okay, when you try to explain, okay, you just tell them that, okay, this one is 2m HCl 20 cm3, 2m NaOH, so you're anticipating 20 cm3 as well. Okay, so equal molar concentration of NaOH require equal volumes, okay, to neutralize each other. So therefore, if we have 30 cm3, okay, that is in excess. So therefore, the solutions will then be in alkaline. Okay, so that will be part B. Part C, explain why the temperature of the solution dropped after adding more than 20 cm3. Just like what we have said, okay, this part, okay, temperature drops, okay. You have two things to explain. One, okay, you have to remind them neutralization have already been completed. Second, excess addition of NaOH will only bring down the temperature. Okay, so you have to see that, okay, no more heat is given out when neutralization is complete. Okay, addition excess will cool the reaction mixture. So therefore, you will find that the temperature will drop. Okay, part D. Okay, it is not difficult, but just want to pay attention. What is the maximum temperature change? Okay, remember, maximum temperature and maximum temperature change is different. For changes, okay, remember, you have to do a subtraction. Okay, use the highest minus the original temperature. Okay, this one and this one, you have to do the subtractions to see the difference. Okay, part E, okay, it stated that if we have 40 cm3 2m HCl neutralized by 2m NaOH, what will be the maximum temperature change? Okay, just like the previous one. Okay, in this case, okay, we have increased volume of HCl. Can you see that? We have 40 cm3. Sorry, we have 40 cm3 change from 20 cm3. That means you have more HCl here. If you have more HCl, you should need more NaOH to neutralize it. Okay, however, both of them, they have the same molarity. So you anticipate you need more volume, much more volume of NaOH to neutralize it. Okay, so at the end, okay, you really have doubled the number of mole of HCl or H2O form. How can I know that? Okay, because right here you find that 2m HCl, okay, and then you have 0.04 dm cube volume. When you multiply this one, you have 0.08 mole. We're anticipating you have 0.08 mole of water form, okay? But originally you have 2 times 0.02. That means you have 0.04 mole H2O. So obviously more water formed. More water formed, that means more energy released. However, just as we mentioned, not only consider the energy release, okay, but also we have to consider how much is the volume of the reaction mixture. So in this case, okay, originally we have 40 cm cube because 20 plus 20. Okay, but now, okay, you have 40 plus 40. That means you have 80. So even the temperature is doubled, okay, the volume you're going to heat up with is also double from 40 to 80. Is that right? So therefore, in this case, okay, we'll find that the temperature rise will be more or less the same. So it will again about 18 degrees Celsius. Okay, so how are we going to present the whole ideas? Okay, you'll find that although the volume of acid alkaline used are double, number of mole of H plus and OH minus react is also double. Twice the heat given out, but used to heat up twice volume of solution. Okay, so therefore we will find that, okay, the temperature will be the same. Sorry about that. Okay, I really highlight the whole paragraph, but this is what we are doing. Okay, so just want to summarize, okay, the two examples that we have done just now. Okay, in order to know that the temperature rise, how the temperature rises, okay, so there are two factors affecting that. One, okay, that will be the water formed. The more water formed, more energy release. How can we know the water form? Okay, you calculate number of mole of H2O. Okay, roughly you can know that, okay, how much water will be formed, and then you'll know that whether they have more energy release in the modified experiments or not. Okay, but at the same time, if you consider the volume of the reaction mixture, because larger the volume, more energy required to rise by 1 degree Celsius. That means if you have larger volumes, okay, actually you need more energy, okay, to have the temperature rise. If you give them the same same amount of energy, actually the temperature rise should be lower. Okay, so we just have a look of 3 cases here. So we just take a look of the original one first. Okay, 2MHCl, 2MnOH. So in this case, okay, water formed will be 2 times 0.02. So we have 0.04 mole of H2O. And the total volume will be 20 plus 20, that means 40 cm cube. Say for example, for this one is rising by X degrees Celsius. If I modify the experiments, okay, to the one on the right, you'll find that, okay, we multiplied the volumes, okay, we doubled the volume of the acid and alkaline used. So in this case, okay, 2 times 0.04, yes, we have more energy given out because we have more water. Okay, however, we have doubled the volume as well. Double the volume from 40 changed to 80. So therefore, even you have more energy given out, but you're going to heat up double volume. So we'll expect that, okay, the temperature will more or less the same. Okay, but in the case on the left hand side, that will be different. In this case, you'll find that, okay, we have a double concentration of acid and double concentration of alkaline. In this case, okay, when we multiply 4 times 0.02, it will be 0.08 mole of H2O. So you will find that the energy will be doubled. Okay, the energy doubled in this case. Okay, doubled energy, more energy given out. Okay, but the volume that you're going to heat up with, they are the same. When you have more energy, heat up the same volume, then you will find that, okay, we'll have temperature rise. Normally, it will be double of it because you have double amount of energy. Okay, so when you consider whether the temperature rise or remain the same, okay, you have to think about 2 criteria. One is about the water form. Second one is the volume of reaction mixture. So to summarize these videos, okay, you have to know that, okay, neutralization is a exothermic reaction. exothermic reaction. That means heat is given out, okay? Heat is given out, okay, during the reaction. Okay, and then we'll find that the temperature will rise. Remember, you have to sketch the setup and know the function of the expanded polystyrene and also for the styrene cup and also the air. And you have to know that how to find the highest temperature properly by constructing two lines, finding the intersections, okay, at the highest point. Remember, this is a best fit line, okay, so try to align more data, okay, on the line. If it is not, okay, make sure the data should be some on the left, some on the right of the lines, okay. And also we have experience, okay, we have to learn about the factors that are affecting the temperature rises during the neutralization. Basically, okay, it's based on two things. One is the water formed in the process. The more water formed, more energy will be released. Second one, they will be opposite to the effect of water form. That will be the volume of reaction mixture. If you have a larger volume of reaction mixture, more energy it is required to rise the temperature. So when the water formed is getting more, but at the same time, if this one is doubled, water form is doubled, but volume is also doubled, then actually they will cancel out each effect. Okay, so pay attention to all these factors when you examine the temperature rises during neutralization. That's all for this video. Bye bye.